All right, here's another calculation you'll need to learn how to do, and it's called percent composition. And right, you're all familiar with percent. Percent just means part per 100. So if you had a 100 question test and you got 80 out of 100 correct, 100 is the total number, 80 is the number you got correct, so that would be 80 divided by 100 times percent, 100 for percent, so we'd have 80%. All right, so it's a concept you're familiar with in everyday life, but let's apply it to this chemistry situation. We want to find the percent composition of each element in a compound. All right, so the percent mass of element A in compound A is how much element A contributes to the total mass times 100. And so let's look at a quick example. What is the percent composition of hydrogen and nitrogen and NH3? So what we want to do is find the molar mass of NH3 to begin with. And remember, to do that, we need the mass of all the parts that make up this molecule. So we look at it, it's NH3. That means we have 3 hydrogens and 1 nitrogen. So then we would go to our periodic table and say that each hydrogen contributes 1.01, each nitrogen contributes 14.01. So there are 3 hydrogens, so you're getting 3.03 from the mass of the hydrogen and 14.01 from the nitrogen. So that total molecular weight is 17.04 grams per mole, right? So that's the total mass of the molecule there. So what we want to do now is we find the percent mass is the mass of A divided by the total mass. So for hydrogen, its contribution is 3.03, and the total mass is 17.04. Sorry, that's really messy, 0.3. And then we're going to multiply that by 100 to get the percent. And then out of that 17.04 grams, 14 of it is from the nitrogen. So we divide that by 17.04 and multiply that by 100. And so we take our 3.03 and divide it by 17.04. And it gives us 17.78%. And we take our 14.01 and divide it by our 17.04. It gives us 82.22%. Right? And so it's kind of interesting to look at here and think about what we're doing. Is this ammonia molecule contains 4 hydrogen, but since each hydrogen atom is so light, those 4 hydrogen only contribute about 18% of the mass, and there's only 1 nitrogen, but it's so much more heavy. It's 14 times more heavy almost than each hydrogen atom. It contributes almost 83% of the mass.